morning. Welcome to our intro to our workshop. I'm Sepehr, the instructor, one of the 4 instructors for this course. Very excited to see you all this morning. So today we have Emma in the back, who's also going to help us in teaching R. Homer, most of you are familiar with. Also another instructor, and also Eric. Eric. Last one. Okay. Homer and I started these series of R workshops about a year and a half ago, and so far we have had more than 8 workshops on either intro R or advanced R programming, and more than 300 students so far. And over time, we try to make this course better and better, more kind of a hands-on experience that you can type and you can learn all while I'm teaching you. Hope you enjoy the class. A few things, we have a channel in Slack that, or if you can explain it, how people can join.
Yes, so you are going to be the first Data Science Initiative workshop where we're experimenting with having a chat room for today's workshop. It's optional, but recommended that you sign on so that you can chat with each other and ask questions, and the instructors will also be on Slack, so hopefully we can sort of help answer questions. If you have problems or whatever, you can also just raise your hand and one of the instructors will come and help you, but Slack is a nice way to communicate. So basically it's a chat room, but it's a nice chat room. So to go to Slack, you go to UCI Data Science Initiative.slack.com. There's a link to it in the README of the GitHub repository for this workshop. So if you found the GitHub repository, you can just look in the README for a link to it. If you have a UCI email address, then you can create an account on Slack and sign in. If you don't have a UCI email address, then email me and I'll invite you.
So what is the address again?
UCI Data Science Initiative. Oh, sorry. UCI Data Science.slack.com. Yeah. So Sepehr here is looking at the README on the GitHub repository, and there's a link right there.
And you need to create an account.
Yeah.
I guess it's taking a while to get to conference.
Just type into your account.
So, to access our slides, you could go to the URL on the top. If it's not big enough, I can make it bigger for you guys in the back.
What I'll do is I'll just put that URL into the Slack channel so that everybody can just get in Slack.
Okay, to access our slides, you can go to this URL, UCI Data Science Initiative.github.io. This part is the name of the repository, so it's case sensitive. Make sure that I is capital, R is capital, then we have underscore, workshop with capital D. So you can access our slides. This is, okay. General layout, that's what we are going to do.
I'm sorry, I just get a list of files, you know what the...
There's a little link right at the top there.
Yeah, so if you go to this link.
Thank you.
Okay, so this is the layout for the workshop. The morning session is mainly focusing on basics of R programming, the basic data types that we need to know, some of the syntax, basic syntax to do R programming. And we'll learn the basics of how to program in R. In the afternoon session, we are going to do more type of data analysis, data exploration, data visualization. So. I highly encourage you to find a partner and try to work in pairs. And as we go over code and explain different topics, please try to type them, test them. R is a command-driven programming language. You can type, see the output, whether you get error, whether it's working. So I highly encourage you to type them and test them on your own. And as I said, to access the presentation, this is the link. We put all of the workshop material, including slides, codes, exercises, into a repository. If you're familiar with GitHub, into a GitHub repository. So you could go to this address and download the whole repository. So when you go to this address, this is going to download a zip file that includes everything we are going to talk today. Okay. So if you haven't done that yet, please go, click on this one, download the whole repository. We are going to use some of the files in that folder. Okay. So, R is a free software environment for statistical computing and graphics. I assume that most of you are familiar with R or have some objectives in mind to start learning programming in R. You could get a lot of information from our website, including some very useful tutorials. R compiles on pretty much all platforms, Windows, Unix, Mac OS, and one very useful thing about R is open source and free. If you are a MATLAB programmer, you know that for MATLAB you need to buy license R, open source, free, and so many people, especially in academia, constantly contribute to R, and it's free and you can use. R is a command-driven system. As I mentioned, when you open an R program, you can type a command and see the output. If you have experience programming with other languages, like some of the compiling languages, like C++ or Java, you need to write a program, compile it, and wait to see whether it works. It's compiled properly and then test it. It's not the case with R. R is interpreter, command-driven. Type a command, you see the output. So in that sense, it's very easy to learn R programming. And if you are familiar with object-oriented programming languages, everything in R is object. Okay? And we are going to see more about this, but whatever we have, if we have a regression line, that's an object. If we have a graphics, that's an object. If we have a variable, that's an object. Associated with each object, there are some attributes. We are going to learn them. In programming with R, we are going to use RStudio. Consider RStudio as some sort of like beginner term editor that you can type your commands, or in a more programming type, definition, RStudio is integrated development environment. I assume that most of you have RStudio and R already installed. Who doesn't have R or RStudio on his system? Okay, great. So, and as you noticed before, in order to install RStudio, you need to have R installed already, and to install RStudio. If you need more information, you can go to this URL on our GitHub repository. When you go to this URL, you see a README file here. This is our repository, and you see a detailed instructions on how to download and install R and RStudio. Okay, so let's start with RStudio. This is RStudio window. So please open RStudio. If you open RStudio, you may notice that your RStudio, your version might be a little different from mine. Okay, so you can customize different windows. If you go to RStudio in Mac or in Windows, you need to go to Tools. There is something called Global Options under Tools. Okay. So if you click on Global Options, if you go to Appearance, there are different backgrounds that you can choose. I'm more comfortable with type of a dark background when I do programming, so I chose this one, so you can do whatever you want. And there's a layout window. So in layout window, you can change the layout of the program. So let's go back to R and see what we have here. And if you all click on this little plus top left, and then let's click on R script. So you see in R script is a place that you can type your command. Type. So in this window, we have one part for R script. Yours might be in the middle. We have one part that we run our commands. Okay. So one simple example: x is equal 10. This is our command. We need to run it in the R window. Okay. So we have two other windows. This one that shows what types of files we have. If we have a pod, it shows a pod. We don't have any pod at this point, so it's empty. And we have another window that is for the variables that we have defined so far. Okay. So now let's go back to preferences. If you go to layout, you see a source part, which is the part that you type your commands. The console is the part that you run your commands. Environment is this part that we have our variables and file and pods. Okay? So you can simply change this layout. So in this case, my source is this window, console is this window, and the other two windows. You can easily change this by clicking here and changing to something else. You can have console here and source here. Okay, so you can customize it whatever you want.
What would you recommend for this workshop?
I usually do source on one side and console on the other side because I maximize these two and I do programming. These two windows are not used very often. So I would rather have console and source, the top two windows, so I can maximize them. Okay. Any questions so far?
How do you access that window?
Are you a Mac user or Windows user?
Windows.
If you go to Tools, under Tools we have Global Options.
Okay.
And if you click on Global Options, you see that window. And Layout is the fourth one.
Okay, thank you.
Okay. So what I usually do is I maximize these two windows. Okay. So this is console or R program where you run your commands. This is some sort of editor that you type your commands. Okay. it's not enough to just type a command here. You need to run it in this window so that R knows something like X exists. Okay. So, when you open R first time, you see a lot of information here. To clear this one, you could do Control and L. Control and L to clear that. Okay. So we all open our script window. Okay, this is a place that we just type all of our commands. Okay, so you can save this in the local directory. We are going to type all of our commands here and then run them. So, in R, we have 5 different data types. If you are familiar with variable, how many of you have programming experience before? So, when variable x, let's go to here. Variable x is a cell in memory. Okay, so it's a symbol for a cell in memory. So you have a cell. We can assign a symbol. Here we define that symbol to be x, and to that symbol we can assign a value. In this case, we are assigning value of 10 to that cell in the memory. Okay, let's call that variable. In R, you can assign a value to a symbol with equal sign. Here you have equal sign. Another way is to use a little arrow, which is less than hyphen. We are assigning value 10 to x. Let me make this a little bigger.
Do they have different priorities? Equal and less than?
Both of them, you can use both of them. I would rather this one, and I explain a little why what's the difference is when I explain functions. Okay, so we have symbol 10, value of 10 is assigned to x. Okay, so to type this one, R doesn't know x exists until we run this in the console. You can do copy and paste in the console. Okay, here's the command driven part. X is 10. Now, you run a command, and you ask R what x is 10. So note that next to 10, you see bracket 1. Bracket 1 is that 10 is the first element in x. Okay. If you program with other languages, so some languages like C++, like Python, they start from 0. Indexing starts from 0. In R, it starts from 1. The first element in x is 10. Okay. And the question is, why R bothers to have this 1 here if variable is always a length 1? Fact is, the most basic object in R is vector. Okay. Vector is combination of elements. Okay. You can put different elements next to each other and create a vector. Okay. Variable is in fact a vector of length 1. Okay. The most basic object is vector. Vector of length 1 is just single vector. So here, in fact, x is a vector of length 1, and the first element is 10. Okay, so now talking about variables and vectors, we have different types. Here in this case, we have a numeric value, 10. We can have y as a string. Okay, when we have a string, you put it in double quotation. Okay, string is a combination of characters. When you have characters, you put them in double quotation. And then we have a symbol or a cell in memory. We are assigning a value to that cell. And we use this little arrow to assign that value. Okay, so again, we can copy and paste in the console, and you can type y to see what the value is. Again, y is a vector of length 1, and the first element is height. We can have logic. Oh, yeah.
Do single and double quotes have different significance
No
in
difference.
this language?
No difference, yeah. You could use either. Sometimes you have a string, combination of characters, and inside that string, you have a single quote. Okay. In order to do that and to assign a variable with that single quote inside, you need to use double quotation. Other than that, no difference. You can have a logical value, called logical val. So again, this is just a symbol. You can use any name you want. Okay, I use logical val. And this name should not be one of the reserved words in R. Okay, you don't need to memorize all of them. Like gradually you learn that we have something that does something, so you can't use that. You know, if you have like function called mean, we are going to see what function is. But if you have something called mean, and you can call that mean and vector and get apples, you can use mean as the name of the variable. Okay? So, logical value, like true is a logical value. Logical values are either true or false. Okay? This is how we type them. True, all capital. Even if it's still character, but R understands that true is actually a value. So you don't need to put it in double quotation. You need to be all caps. And I can have another logical value, and that logical value is false. So I get false, all caps. Okay? So again, I can copy and paste into the console. If I don't do that, let's see what log_val1 is. There's no object called logical value 1. Again, everything in R is object, so R is looking for an object. There's no object there. But when I copy and paste this guy into the console, and then I call this variable, R now understands that the variable exists. So it's not enough to just type it. Okay. So a short key, instead of copying and pasting, is command and enter in Mac. I believe it's control and enter in Windows. Okay, you can just select it, command and enter. Okay. So now we understand what variable is. Let's see what different types we have. Numeric, number, integer, a specific type of numeric. Numeric can be like in other languages, sometimes we call it float. We can have decimal places, integer, no decimal places, whole number. Complex, a number that you have a real part and you have an imaginary part. Logical, we saw an example, true and false, all capital. And character, or string. Okay? So,
Sorry, what's the difference between numeric and
integer.
integer?
A value like 1.5 is a numeric value. Okay. 1, we are going to see that. 1L is the whole number and it's an integer, no decimal. Okay. If you just simply say 1, or even if R shows prints 1, but you consider 1.0, you consider it a float. But when you do 1L, it's an integer, it's a whole number, no decimal places. Which you rarely see the difference. So we understood that the most basic object in R is vector. We saw an example of a vector of length 1. Okay, let's see other vectors. If you open this slides in your browser, in Chrome, you could just copy and paste, or you could just type it in R, which I recommend later. To put some comments in this code, in this environment, you could use hashtag. Okay? If I in R say this is my comment, I get an error. R doesn't know what this is. When I do hashtag, R understand that this is some comment, and it's not going to read that and to interpret that. Okay? This is my comment. I highly recommend when you write your code, put comments. But later when you go back to your code, you understand what you did. Okay, so I put hashtag vectors. Now I want to learn what vectors. and this is of size larger than 1. Okay. So I define a numeric vector. Okay. Numeric vector is the name of that symbol. It's a symbol for that memory or cell in the memory. Okay. And I assign value to that symbol.
When you name a vector, is it case sensitive, or can you just?
It is, yes. If I do x equal 10, and then I ask about capital X, no X exists. Okay. So in this case, thanks for asking. So I have numeric vector. Inside numeric vector, I want to create a vector. Vector is a combination of elements. Let's combine elements. So in R, we use C operator to combine elements into a vector. Okay, C parentheses, the first value, second one, third one. So I have a vector of size 3, which is a combination of these single elements. And I use C operator to combine it. Okay. So now this is a vector. I can run this, and I can print out a vector of those 3. Okay. 1 refers to this element. This is element number 1. So this is 2 and 3. Okay. So make sure that you have this C operator. Otherwise, you get error. R doesn't understand what this one is. 1, 2, 3. Error. Unexpected. It's not known. So you need to use C so that now we have a vector. Okay. Now let's do another numeric vector. So I intentionally use the same symbol, numeric vector, and I define 12 to 120. Okay, this is a new symbol. If you're interested in sequence starting from 12, ending in 120, with a step size of 1, you can do 12, colon, 120. Okay, so I can run this guy. Now I'm using the same symbol that I used before. I'm assigning a new value. So I don't have this value anymore. I have a new value for this symbol. Okay, so let's type numeric vector. So I see all these numbers. What is element number 27? What's that, 38? No, element 27. Element number 27.
38.
38. 25th? This is the 25th, 26th, 27th. So that's why we have these stuff in the R. And it's handy when you look at the data, you can go quickly to the specific element. So in this line, the first element is 12. In this line, the first element is element number 7. Okay? Okay, so this is a new way to create a vector. Obviously, if we do logical vector, and again, I can combine different elements. Let's do the first one false, the second one true. Okay, so these are different ways. You can type the whole thing, or you can do just neutral, true and false. Okay. So instead of writing true and false, just initials T and F. Okay. So an example of a numeric vector, you can simply do character vector by using C operator, combining characters into a vector. Here we have strings or characters combined. There's another way to define a vector. That's by using vector function. We're going to see more of these type of functions, but we have something like a box, like a black box. And this black box gets some inputs, returns some outputs. This black box here is vector. Is a function, that box, gets some inputs, which are the arguments of this, and returns some output, which we store that output into a symbol. So we store whatever this returns into logical vector. Okay. That function is called vector. Has some arguments. What type of data we are interested in? Mode, we are interested in logical vector. And we want a length of 10. Okay. So, now, suppose that we don't know anything about
What you said about it being a black box, I don't understand.
vector is a function. Does something. You don't care about the inside, that how it manipulates objects and how it combines things. It's just a function. You put inputs in and you get the outputs. And you don't care how that function changes input into an output. Okay. So we have something like vector that gives arguments, generates a vector for us of length 10 and of type logical. Okay? Suppose that we don't know anything about vector. You can simply do question mark vector and you can hit tab in our studio and you get some conclusion. You choose vector and let's get some information about vector. By question mark you can get some information about a function. So vector is a function from a package called base. We're going to learn more about package. For now, consider package as a library or a folder that includes a set of commands and data sets. Okay, so vector is a function from a folder, and let's see what arguments we have. Here's how we need to use vector. Vector gets two arguments. The first one is mode, the second one is length. Okay. And when you go to arguments, you can see details on how to use these arguments. Mode is a type of variables you're interested in, and length is the length of the vector. Okay. So here, when you look at vector, you see the argument values, and you see equal signs. This means that there is a default value associated with every argument here. If you don't mention anything for mode, R is going to use the logical mode, because there's a default value assigned to mode. And if you don't mention anything for length, R is going to assign 0 by default to that argument. So when you do question mark vector, you get information on a function or on this object. Has some arguments. Since we see equal sign, there's a default value for those arguments. Okay. So now let's try this function. I have a logical vector of length 10. So I can print this log vec. Again, you can hit tab and use auto-completion. I'm interested in log vec. And this is my vector. Okay? So vector log vec is an object. Associated with the object, there are some attributes. One of them is called length. Length of this vector is of length 10. Vector length 10. Okay, let's use this one again, and let's just ignore the first argument's mode. Okay. Just type the length. I type length 5. Okay. I still get a vector of logicals, not numeric, not character. And the reason is mode has a default value, and that default value is logical. Okay. Is it clear to everyone? Okay. So this is another way of defining a vector. In R, we have some special values. We saw one of them, L. If you do 1L, 1 is not a numeric, it's an integer. There's a constraint on it. There is no decimal places for that. It's just a value, 1L. I don't know why they use L. It makes sense to have like I as integer or something like that. R understands infinity. Infinity, capital I, and F, and negative infinity. So, if you type X is infinity, and this, R understands that X is infinity. Okay. So, and similar for negative infinity. Let's try negative X. Suppose I define A0 and B0. So I have A0 and B0, and I look at A divided by B. So R returns this is another specific value, which is not a number. 0 divided by 0 is not defined, not a number. Okay, this is another specific value. So we talked about logical vectors, different ones, either the whole thing or just the initials. An example of a complex vector that you have the real part, you have the imaginary part, which you shown with I. So very clear. And again, an example of a character vector. There is one limitation with using vectors in R. And that limitation is all elements within the vector should have the same type. You cannot combine characters with numbers. You cannot combine logical values with numbers. Okay? So let's see what happens. I define a mixed vector, and that vector has number 1 and a character. What do you guys expect to see? What is the outcome of this? So I'm combining a numeric value with string, and we know that R does not accept combination of these two. What do you guys expect to see if I run this? Pick one as a character. So you don't see any error that you are combining different elements of different types. But when you type this one, you see some sort of coercion that 1 is now considered as character. And the reason is you see double quotation. So we have some sort of implicit coercion when you combine elements of different types. And these coercions are predictable. They are not just random coercions. Every time you combine number with character, you see that number coerced into character. So you see different types here that if you combine a value, this is a numeric value with this is going to become a character. If you combine pi with a logical, what do you guys expect to see here? Combination of numeric and logical. Numeric, so what is that vector?
Pi and 1.
Pi and 1. True is mapped to 1, false is mapped to 0. Okay. So this is implicitly coerced into pi and 1. And here, character and logical. Character. So you see double quotation for true. So true is now character. Okay. So obviously, when you have characters is now character, you can't do other stuff like multiplication, summation, stuff that you do with numeric. If you have 1 coerced into character, it's now character. Any question? Okay, so we saw a limitation, a restriction on vectors, and we saw that R doesn't return any error if you combine different types. It just does some sort of implicit coercion, and that is predictable. We know that what coercion is going to be. Okay. But in R, we also have implicit coercion. You can implicitly tell R that change this vector from type A to type B. One example is you have information on students and you have their student ID. You want to make sure that that student ID is treated as ID and not a number. You want to make sure that if someone is using that ID, he's not going to look at average, summation, and stuff. So one way to make sure that it's ID is to coerce that from numeric into character. Okay. So to do that, you can do explicit coercion in R, and we see an example. So suppose that I have my numeric vector, and that is 1 to 10. And if I type here, see my numeric vector, then I can coerce this numeric vector by using as function into character. now you see that the outcome is like the same vector, but now every element has double quotation, meaning that this one is now vector. Okay. So. In R, and like the goal of this workshop is to teach you the basics of R programming and to show you how you can get help by using online resources and to be able to improve your skills in R programming. So while we teach the main concepts, we try to introduce new functions. Okay, so we have a new topic, we try to introduce new functions. Okay. So we have a function here called sequence. Numeric vector, a function, get some argument called sequence. What sequence does? Yeah. You get a sequence basically from a number to another number. To get detailed information, question mark, sequence. Okay. And use question mark sequence when you know the actual name of the function. You know that it's called SDQ. If you don't know, you do double question mark, and R looks for all functions with the similar names, and you can choose among them. So we have something called sequence. Again, it's from a folder called base. We're going to soon see what base is. Get some arguments. We have an example how to use from, to. So note that from has a default value, to has a default value, and the rest of them all have default value. Okay, so you can see what from is, what to is, what by is, more information. Let's go back to this example. We have a sequence from this number to this number where step size is 15. The first one is 1200, the next one is 1215, the next one is 1230. Okay? Let's try this one. Okay, now we have a numeric vector. You see that numeric vector, again, you can get the length of that numeric vector. Just call it. Okay. So, you have an equation here that you use as numeric vector before some integer character. Another equation, you have here a vector of logical. We can do as and change that into numeric. What happens if you change this a vector of logical into numeric? What do you expect to see? Exactly, 0, 1, 0, 1, 1. So when we do coercion, we should be careful and we should consider all the warnings that we get from R. Okay. Let's try this one. We have a vector of complex numbers, and let's coerce that into numeric. Let's see what we get. So, and as you see, when we change this into a vector of numeric, we get all the imaginary parts. We get a warning from R that the imaginary parts discarded when you do the coercion, and you get a vector of only the real part. Okay? You need to make sure that that is the thing that you want. So consider all these warnings when you do coercion. Another example is we have a vector that with strings, with characters, since we see double quotations, and we want to change this into numeric. Okay. If you have 0 here, it's not a case that you get 0. You get NA for this value. Okay. So when you do coercion, consider these warnings and make sure that that's the type of coercion you're interested in. Okay. So here we have 0, and R tries to coerce this into numeric. And 0 is not like the actual 0 to change it to 0. So R looks at this one and realizes that this is not a number, and there's no way to change it into there's no it's just one way to coerce that. There might be different ways, but it's not just one way. So R returns something called NA. NA stands for not available. Anytime that you see a missing value, it's not available in A. Okay. Any question?
So the NA takes up one position in the index.
Exactly. Absolutely. Yeah. Let's try this. Okay. So character vector, the first one of length 5, and you see this one's also of length 5, and then that's the last one. Okay. So we learn variables, we learn different types of variables, we learn what vector is, and the most basic one is a vector of length 1. Associated with every vector, there is a length, and you can just type length on that vector and get the length on that vector. Now we have another type of vectors called factor. Anyone familiar with vector? With factor? Okay. So sometimes you have a vector, and elements of that vector, it can be grouped into a few groups. Like you have vector of gender, and you see male and female. Even if all male and females are in double quotation and considered as strings, but all of them are grouped into two main groups, male, female. This is an example of factor, a factor variable. So factor variables can be ordered or unordered. If you have an example of gender, male and female, there is no order between male and female. It's a factor variable, it's a factor vector, because we have two groups, male and female, but there's no order. If you look at students in elementary school and you have their grades, grade level, grade 1, 2, all the way to grade 6, for instance, these are different categories, so this is an example of factor, but there's also an inherent ordering that grade 1 is before grade 2 and grade 2 is before grade 3. Okay, so whenever we have groups, we tend to define a vector of type factor, and factors can be either ordered or not ordered. Okay, why do we care about factors? Why it's important? In your statistical analysis, in your regression, when you have a categorical variable, how do you treat that categorical variable? Do you just simply change female into 0 and male into 1 and interpret the coefficient as one unit change in gender is equivalent to? So one common way is to define different groups, define them as factor or categorical variable, and then fit the regression for one group as opposed to another group. Okay. You consider one category as the base category, and you treat the other one, you fit that compared to the first one, the base one. Okay. So, and R understands that. R is a statistical programming language. When you define a variable as a factor and you fit a regression model, R understands that this is a categorical variable. One level should be the base level, and other levels should be compared to the base level. Okay, any question? Okay, so let's see an example. Okay, so I define the new vector. Symbol I assign with little arrow and something. This time I have a new way of defining vector. I have a base vector of length 2, female and male, and I replicate this vector. I replicate it 3 times by using a function called rep. Rep is a function that does replication for me, replicates this one 3 times. Okay. Again, you want to know more about how rep works? Question mark rep. So I define gender, and like a gender. This is the gender. So far, gender is a vector of type character. Okay. So my goal is to change this character vector or a string vector into a factor. So to do that, there's another function called factor. You call factor on your vector. So I call factor on gender.
You're creating a new symbol,
Absolutely.
or recoding that.
I create a new symbol. So gender is the original one. Gender factor is the second one. Okay. And the reason is I want to compare them. So this is gender. Now let's do gender factor. Okay, to see the difference. So when you do gender, which is a vector of strings, you see double quotations. When you do factors, no double quotation, and you see something, levels, female and male. Okay. And in levels, this is actually the order of levels. R considers the first level female and the second level male. Okay. Why do we care about the order? This is not an ordered factor, but yet it sees something like levels.
So it's not ordered?
This is not ordered.
It's not
No.
ordered.
What's the reason?
Because if you're going to run, say, a regression included as a factor, you want to know which is the factor part you're leaving out, right? So you won't know which one's the one with zero and the.
Absolutely, absolutely. Yeah, when you run a regression, you want to know what the base level is. In this case, the base level is female. Okay. But the question is this the best way to order these levels, or is female the best group to be the base, to serve as the base level? Okay, what R does is just, R looks at this vector and sorts them alphabetically. And female is before male, so female is considered as the first level and male as the second level. So when you run a regression, female is the base level, and we get coefficients and we get estimates to compare male to female. But the question is this the best way to do that? Do we normally do this in the statistical analysis? How do you choose the base level?
You assign it, don't you somehow?
You assign it, but how you decide which level is the base level?
Depends, I guess, on your question.
It depends on the question,
Like,
but
for instance, if you have freshmen versus seniors, if you think seniors have more scientific knowledge, you would make freshmen a comparison, right? Compare the.
yeah, you could do comparison between freshmen versus senior, or you could do seniors versus freshmen. The question is which one is better. Suppose that freshmen are like, I have a data set, and freshmen are 9,000 vectors, and seniors are 90 vectors. Which level should be the next level? Freshmen, because freshmen, we have more information on freshmen, and that represents the actual population better. So we want to put that as the base level and compare everything else to the base level. So whatever represents the population better should be the base level. And we compare everything else to the base level. Okay. So, and part of it could be frequency. Here, it's just sorting them, and female is the first one. So you don't want to change this ordering. And the question is how we can do that. So if I call levels on this factor, I see my levels, female and male, and they are ordered. When I do, let's do a question mark factor, if you look at what factor does, or what the elements are, you see something like levels. And levels has no equal sign. There is no default value. Besides the levels. Yeah. So I can, when I define my factor, in this case, I can add additional element levels. And levels are male this time, and female. I can run this generic factor. Now I see that the order is now different, male and female. So for each factor, you can change a vector into a factor vector. And by adding additional argument called levels, you can set the order of levels as you want, and depending on your question of interest and on your data. So any question so far?
When we are changing the data types to a numeric to character, so we were using as numeric as character. But here we are just using like factor instead of using as. Is there any difference?
No, actually. Well, factor is a function that has additional arguments that you can use. If you ignore those arguments, you can just do as factor and call it as factor on a vector. Yeah.
When you say so, intuitively I see like I can convert as using as factor.
Exactly. Exactly. You could do as dot factor. Similar to the as function can be as, and as an argument you can say numeric, or you could say as dot numeric on a vector. Okay. And it's also the case for factor. You could do factor as a function with additional arguments to decide on the levels, or you could just simply do as dot factor on the vector. Yeah. So, once you have a factor, so you are telling R that this is a factor, we have clusters, we have groups, and so we define levels. You can call table on factor, and R generates a frequency table. Okay. And columns are actually the levels of that factor. So another thing is, now suppose that I have a factor here. I have a factor vector here. I want to unclass the factor. So we did one way, we converted a vector into a factor vector. How can we do the other way? Changing a factor vector into a non-factor. You can do unclass. Okay. Let's do unclass. Here's this one. I can do unclass, and you get a list of 2, 1, 2, 1. Okay. And it's different from female and male. What 2 is the second level, 1 is the first level. In this case, levels are male and female. So the first one is female, the second one is female. So when you do unclass, you get a vector back. The elements are the order of levels. This first element is the second level. The second one is the first level. Okay? Sometimes you need to change that. Any question? Okay.
How did you switch the, you said before the female was a base. How did you switch that to the male?
I added another argument to my factor function called levels. And inside levels, I explicitly mentioned that I want the first one to be male and the second one to be female. Let me give it again. So I have gender here. And female, if you sort them alphabetically, female is before male. So if you just simply say factor, gender, you get levels where female is first and male is second. But if you add additional argument called levels and explicitly mention that I want the first one to be male and the second one to be female, you get the other. Male first, female second.
And we did the unclass because we defined male as the base level. assigns it the value of 1,
Exactly.
and then it moves up from the factors from there.
Absolutely.
But, okay, but then when we generated the symbol, we started with female, and that's why it starts with a 2 and a 1, the output from the class.
Exactly, because we have two types of things. We have a vector, and we have the actual values. And we have here some sort of mapping that based on levels, male is first and female is second. When you use this mapping, and the result that we get from the unclass is female is the second one, male is the first one. Okay. And factors is not necessarily 2 levels, can be more than 2, like the example of the schemas that we saw. So, any other questions?
I would note the levels of the factors are really important and are kind of like a gotcha when you're doing data analysis, because sometimes you'll subset a data set and then there will be fewer levels present than all the possible levels. So like maybe the levels are all the states, but then you're only looking at a couple of different states. So the factor variable might know about all the states, even though they're not all present. And so if you sort of don't know about the factors as a data type, then it's kind of confusing because you might be confused about whether or not they're actually in your data set. And so something to sort of be aware of and something you can manage is whether if you like subset the data, do you want to also subset the levels to only represent the levels that are present in the data? Or do you want the levels to represent all the possible values of a categorical variable that are in your data set? And so this data type kind of allows you to go either way, but it's something to be aware of.
Like if you like predefine like freshmen, sophomore, junior, seniors, but there's no seniors in the data, that factor will still show up as seniors.
Yeah, it'll still know that the seniors are an option.
Seniors
Yeah.
and
And that might matter if you're going to combine a senior data set later on, then that will facilitate doing it.
Yeah, very good point.
Same note, if you were to do male, neither, female, obviously we don't have neither in our data set. Would it be 1 and 3 that pop out, or 1 and 2?
I'm not sure how factor does that internally. So, I mean, usually the kind of one of the big motivations for having factors is that you don't really worry which index factor assigns to each of the levels. I don't know how it would do that, but you could choose to add in a neither category, and it would, I guess, n is after m, so by default it would be 3, I assume.
Yeah, well, one good thing with R is you could actually type it and see what the outcome is. You know, you could just simply do not here and see what happens. So now we get figure. Okay. Now I have, even if I don't have any non-value, but I have additional value in the levels, that's called none. Okay, so, and note that here I'm not assigning this result into any symbol. So when I type it, R prints it into the console. And this is useless because you just see it in the console, but you can't go back to it later. Okay, so now I change this into this format that I have my symbol, or I can call it gender factor. This is very nice because every time I need to see the output, I can just call this and see the output. And later, if I need to use this, I have this data stored somewhere. Okay. So now going back to your question, if you do on class, on this gender, you don't have any none, which is the second level, so then female becomes 3. Okay. So that's a good thing with R, that you can just try and see.
So one other comment about the motivation for supplying and ordering for your levels, even if there's no natural ordering, is that you want your levels to be ordered in the order that you would want to present them on a legend or a plot. Since later on with ggplot2, that's exactly how we'll decide the order in which to show the levels. So when we're breaking things down in a plot by category, the factor levels and the order of the factor levels will determine in the legend how they get printed. And so even, I find often that even if there's not a natural ordering, when you go to make a plot, you somehow have some idea about what the ordering, or maybe your advisor or whatever wants the ordering to be in a specific way. And so that's how you would change it, is you would change the orders of the levels in the factor.
So, okay, and so far we saw this one, NaN, not a number. We had an example, 0 divided by 0, it's not defined, we get not a number back. We saw an example of NA not available when we coerced a vector of strings where we had 0 actual type in English 0, and R didn't know how to coerce that into a numeric value but not available. Question, what is the relationship? If something is not a number, definitely it's missing. So not a number is NA. If something is NA, not available, it's not necessarily a not available number. Might be not available ID that is a string, not available logical value. So NaN by default is also NA, but NA is not necessarily NA. You need this one when you deal with missing values in your data. Okay? You need to detect missing values by looking for these symbols, and sometimes you need to impute them with an appropriate value. So this slide is just to know that we have two types of missingness and how they're related. Okay. So one very simple example. Find a test score as NA, capital N, capital A. Again, R understands what NA is. So there's no need to put the double quotation. It's not string, similar to false and true. So we have NA value, you have data, you have NA inside, you want to know which elements are NA. There's a function is.NA that looks for NAs. So we ask whether this score is NA or not. It is a missing value. And similar for NaN, we have a function whether it's not a number. And we can ask whether it's not a number. So if I ask whether test score is not a number, even if we know test score is usually a number, but since initially we initialized this one as NA, and NA is not necessarily a number, so when you call is.NaN, you get false back. Not necessarily a number. We know that it's missing, it's not available, but we don't know whether it's a number not available or anything else.
So just to comment on, especially for those of you who have programming experience, there does also exist a null value in R, and that's used more for programming purposes, and it's like null or nil in other languages. The NA and the NaNs are things that you would find like potentially in data sets, so they're kind of like more practically important. I don't think we talked about null in these slides.
No. So we learned about vector, the most basic object in R. And now let's look at matrix. If you combine vectors, you can get matrix. So you can combine vectors horizontally and combine vectors vertically. And matrix is like basically a two-dimensional. It can be more than that, but just as the first example, consider two-dimensional. So by using matrix function, we can define a matrix. Matrix gets two arguments, number of rows, number of columns. And question on matrix, again, question mark, matrix. We see our matrix function has some arguments. The first one, data. By default has value of NA. Data has a value. So you have some data, you want to arrange them into a matrix. Okay. There's no need to mention those data when you actually call matrix because there's a default value of it. This means that if you don't mention what data you have, this call matrix is going to fill all elements with NA. That's the default value. Number of rows, number of columns by default form. If you want to use other values, you initialize with the other values. By row equal false means that if we have data and want to arrange them into a matrix, we put them filling by columns. Fill the first column and we go to the next column. Right to the end. Okay.
If the matrix default is the same as like a vector of 1, why would you distinguish between vectors and matrices when you're writing code? Is it for speed or?
Very good question. Matrix and vector are related. If you have like 100 data points and you arrange them into a vector, by adding a dimension element to this vector, you can change that into a matrix. So 100 elements, I do 25 times 4, so I get matrix. Basic matrix and vector are similar, except that for matrix we have additional element combination. But then the question is why we care about having matrix. Sometimes in your statistical analysis, you deal with algebra and you do matrix multiplication. Like if you are feeding a linear regression, you know that our betas, the estimated betas, in matrix format are going to be x transpose x inverse x transpose y. You can deal with all these multiplications by considering these as matrices, and then multiply them together in just one round rather than going to element by element. So it's very important to arrange them into matrix because we are going to use linear algebra to do the computation.
So my question is actually the other way around. Instead of why would I opt to use a matrix instead of a vector? Why would I have to use a vector instead of a matrix?
Sometimes you have like if you have just a sequence of elements and you only work with this sequence, I think there's no need to add any dimensional element to it. Although you can do with matrix of one row or a matrix of one column. Yeah, I don't see any specific examples. Do you think any? I think any time that you have vector, you can use matrix of one row or one column.
Yeah, it doesn't really matter much. But
Okay, so it's not like there's a speed issue?
no, the only thing which I would think of is I actually think that it's better to have matrices even if they only have one column, because then you can use consistently a function I don't really see yet, we'll probably see momentarily, called nrow, which tells you the number of rows in your matrix. For a vector, you would typically use length to talk about like the length of a vector, but if you use length on matrices, then you get like the total number of elements in the matrix. It's not usually something you care about. So rather, if you were mixing matrices or vectors, it's maybe nice just to use the nrow function to be able to sort of like get at the number of rows consistently, rather than go back and forth between talking about the length and nrow. But so that's kind of just more like a programming consideration. But there's no real.
And for you know, like we saw some functions already. Functions have some arguments, and these arguments have some type. It's not like Java or C++ programming that you need to mention the type of the input argument. That the input argument is going to be a vector or a matrix, and you provide something else, or provides errors and returns errors that I can't handle this. So in general, I think there's no difference. For other languages, maybe you need to have a specific type, but not. Okay, so we saw an example that we can use matrix. We want to have 2 rows, 4 columns. Let's run this matrix and call this matrix. All of them are NA. So I think that I may change this code a little bit, and instead of using the data NA default value, my data is 1 to 8. Okay. So the first argument is 1 to 8. I arrange them into 2 rows and 4 columns. Okay, so I have 1, 2, 3, a sequence to 8. This is the default value used by column. Numbers are arranged by column. 1, 2, 3, 4, 5, 6, 7. Okay. So you can simply change this by, and it's very handy in RStudio that you type part of the argument's name and you hit tab and you can see a list of possible arguments. And I know that by row, and I see a lot of help, and by row is the one I need. If I say by row equal true, elements are going to be filled in by rows. So as I mentioned, yeah. So we spend 7 more minutes, and then we can.
Yeah, this clock is totally wrong.
Okay, so matrix is basically similar to vector, but we have additional attributes, and everything in R, object associated with objects, attributes, called dim, which returns the dimension of the matrix. So here, our matrix is 2 by 4, 2 rows, 4 columns. From this matrix, you can use other functions like end row, how many rows we have, or how many columns we have. This is my matrix. You can, you see some symbols here. I'm going to see soon what these symbols are, but just a brief explanation that this is the first column, so the second element is column, and the first element is row. First column, but we didn't mention any specific value for row, which means all rows in that column. So this is 1 and 5, all rows in column 1. This one is the first row, no specific value for column, all values in row 1. Okay? So inside these symbols, you can change them into whatever you want. So I can do call names. I'm talking about my matrix. So I'm changing call names of this matrix. And I need 4 values. So I call it variable 1, variable 2, variable 3, and variable 4. And I call my matrix again. Okay, now I have different names, B1, B2, B3, B4. Okay, and you can do exactly the same for row names. You can do row names, my matrix, and assign the row names. Note that we have 2 elements, so we need to assign 2, a vector of size 2. Okay. So now, to understand better that what's the difference between vector and matrix, which is actually no difference, and they're very similar. If I have my vector, an example here, there is no, it's a vector, but there's no dimension attribute associated with vector. If I add a dimension attribute, I get a matrix. My vector, now I add a dimension attribute, it's a 2 by 4, it's a pretty my matrix. Okay. So I have my vector, I add dimension to this vector, I want to put it as 2 rows, 4 columns. Now when I call my vector, is now a matrix. So matrix and vector very similar, except that matrix has an additional element called dimension. Any question? So there are other ways to create a vector. We know that vector is combination, matrix is combination of vectors. You could combine these vectors horizontally or vertically to define it, to create a matrix. Okay. And why it's important, sometimes in your code, in each iteration of your code, you are generating a vector of numbers and you want to append them into a matrix so you can keep adding them by using rbind or vertically by using cbind. So we have two main functions, rbind, when you bind them by rows, and cbind, when you bind columns by vectors by columns. Okay, so, see. Example very quick. Okay, I have my vector 1, which is a numeric vector 1 to 4. I have another vector, vector 2. After the break, we're going to talk more about what these functions are. So this is my vector 1, my vector 2, vector 3. So all of them are length 4. And now I want to create a matrix so I can combine them column by column. So I use cbind, my vector 1, my vector 2, and vector 3. So I combine them, and now this is my vector. My vectors. Yeah. They are very similar, but not that similar. Okay. So there's something useful, a function called view with capital V. You can call it a matrix. You can see it in the summary. Okay. So let's take a break, 10 minutes, and then we continue.